Dear student, actually go to the some basic concept of chemistry that unit of the next topic, law of chemical combination. Okay, so this law of chemical combination, actually there is a up to the five law is there. Okay, so five law is there. There is a first law as the law of conservation of mass. Actually there is a almost four and five law. There is a five law is there. This five law is very important. They have asking the question. Okay, so there is a first law that is a law of conservation of mass. Law of conservation of mass. Okay, so this law of conservation of mass is nothing but the mass of the product and mass of the reactant must be equal. Okay, so actually this is a, physical or any chemical change. The total mass of the product. Okay, total mass of the product that is equal to, for there is a total mass of reactant. Okay, the total mass of the product that is equal to total mass of the reactant. In generally, the product mass is equal to, that is for reactant mass. Okay, that is a basic simple concept. Okay, for example, see the 4 gram of hydrogen react with the 4 gram of hydrogen can be react with x amount of x gram of oxygen. Okay, oxygen, the 4 gram of hydrogen react with x gram of oxygen gives, there is a 36 gram of water. Okay, 36 gram of water. What is the value of x in this question? Actually the similar like that of many question they have asking. For example, we know that law of conservation of mass, the product mass is equal to reactant mass. Okay, so these two is a reactant, this is a product. So this two is the reactant, this is for the product. Okay, so here 4 plus x is equal to 36. This is for the product, this is the reactant. So x is equal to what? There is a 36 minus 4, that is equal to 32. Okay, the 32 gram of oxygen that can be reacted. Okay, so in generally there is a 32 plus 4 is equal to 36. So we added these two, there is a 36 is equal to 36. So this for the reactant, this for the product. Okay, so therefore the x has a 32 gram. So we know that the element of oxygen, there is a 16 gram. There is a molecular oxygen, that is a 32 gram. Okay, so in generally this equation has, there is 2H2 plus O2 gives, there is 2H2O. So this is a 4 gram, this for 32 gram, this is a 36 gram. Okay, so that's all. See the next law, there is a law of constant composition. Actually, this law is nothing but whenever a pure compound always contain the same elements combined together in the same proportion by weight. Okay, so for example, the water H2O. Actually, this water, it's a molecular formula. That's 2 hydrogen, 2 into 1, then plus 1 oxygen, 1 into 16. We can get, there is a 18 gram. Okay, so one water molecule, it's a weight as a 18 gram. So here this hydrogen and oxygen, there is a two different elements. So this hydrogen of weight as a 2 and oxygen of weight as a 16. Okay, so we can go to simplify this. So there is a 1 is to 8. So whenever that we have collecting the water with various place, that is both place of water possessed as a 1 is to 8 simple ratio of the element of water. Actually the mass percentage is equal to mass of element divided by molecular mass into 100. Okay, so this formula is used finding the element of percentage. Okay, for example, in the law of constant composition or definite proportion, there is a the two place A of place is occurred, there is a copper oxide. It's a copper oxide, that is here, that's 8 gram of copper, 8 gram of copper, and there's a 10 gram of copper oxide, 8 gram of copper and 10 gram of copper oxide. And that is second place, there's B, this place here, that copper oxide 4 gram, same, there is a copper oxide as a 4 gram, and there is a 5 gram of its oxide, 5 gram of oxide. So choose that the given this data, whether this obeying that constant proportion or definite proportion law. Actually here the mass percentage, the mass of copper is 8 gram, 8 gram mass of copper is 8 gram, and mass of copper oxide is 10 gram. Actually the 10 gram of copper oxide containing 8 gram of copper. So that's why the percentage of copper oxide or the percentage of Copper, its a percentage is equal to 8 gram of copper, that's presented as a 10 gram of copper oxide into as a 100. So 0 cancel, so this percentage as 80 percentage of copper as a presented. Okay, anyway, the percentage of oxygen, oxygen, that is equal to 100 minus 80, so that is equal to 20 percentage of oxygen are presented. So there is a place of A, that is presented as a copper as a 80 percentage and oxygen as that is 20 percentage. We compare it to this second place occurred, the copper and oxygen, whether they have same percentage or different, like that. Next we go to that the third law. The third law as a law of multiple proportion. Law of multiple proportion. Multiple proportion. Okay. So this law actually, whenever that two compound, the two element combine to become a two elements combine to become two or more different compound. Two or more different compounds. Okay. So here the formation of two or more different compound, whatever that compound, one element mass as a fixed. Okay, one element mass as a fixed, and another element mass as a simple ratio. Another element mass as simple ratio is obeyed. That is a law of the multiple proportion. For example, here consider as oxygen and hydrogen, these two elements. For example, the hydrogen plus, there is a half mole of O2 gives H2O. Okay, so this is a hydrogen, this is a oxygen. Whatever that, these two as a different element, these two element combine to become as a water. And similarly, this hydrogen and 1 mole of O2 gives H2O2. So here also this hydrogen, this oxygen is not just as a change for that only the stoichiometry. So whatever that, the two different element to become a two different compound. Okay, so here this water as well as hydrogen peroxide. In the case of the hydrogen peroxide and water, there is a one element can be fixed mass and another one element can be, it's a simple ratio. For example, H2O and H2O2. So this mass of hydrogen here is a 2 gram and oxygen of its mass that is a 16 gram. And here this hydrogen of its mass as a 2 gram and this O2 of its mass as a 32 gram. Okay, so anyway, here this hydrogen mass as a fixed value. But in the case of oxygen mass of these two compound as a 16:32, it's a ratio. So we can simplify this ratio, that is 8 is to, that is the 16. Okay, so one more we can simplify this, there is a 4:8. Then one more we can simplify this, 2:4. Again we one more simplify this, 1:2. Okay, so this is a 1 4 and 2 1 4 4 and 2 4 or 8, 1:2. That is for that a simple ratio. So this is a law of multiple proportion. Okay, next we go to that the fourth law. This fourth law actually there is a Gay-Lussac law. Okay, Gay-Lussac law. So this is a actually the volume combines law. It's also called, there's a volume combines law or combining law. Okay, this is a volume combining law. This law actually the similar condition of temperature and pressure. Actually there is a saying STP condition, the standard temperature and pressure condition. Whenever the gases react together, so that's a volume can be representing as the simple whole number ratio. Okay, so volume can be representing there's a simple whole number ratio. Okay, simple whole number ratio. So this is a very important. Actually whenever that this law state that the similar condition of temperature, pressure, whenever the gases react together, the volume of the volume of the gases, the product as well as the reactant bearing a simple whole number ratio. Okay, for example, we know that Haber methods of ammonia preparation. Here there is a N2 plus 3H2 gives, there is a 2NH3. So this 2 is the reactant, this for that product. So this reactant actually the nitrogen has 1 mole and hydrogen has a 3 mole and the product has a 2 mole. So this simple ratio has 1:3:2. 1:3:2. So this is a simple number whole ratio. And the last law, there is a fifth law. This is nothing but there is a Avogadro's law. Okay, Avogadro's law. This Avogadro's law is nothing but similar like previous case STP condition, the standard temperature and pressure condition. There is a equal volume of gases, equal volume of gases contain the equal number of molecules, equal volume of gases containing equal number of molecules. Okay, number of molecules. So this is very very important. So therefore the volume is directly proportional to number of the moles. Okay, so volume is directly proportional to number of the molecules, or number of moles of the molecules. For example, here two applications is there. There is a Avogadro law. One is atomicity of elements. There is atomicity. Atomicity is nothing but number of atoms are presented. There's number of number of atoms in a molecule, in molecules. That is for there is a atomicity. And the molar mass is equal to 2 into vapor density. So this will be used for that upcoming videos. Okay, so anyway, the 5 law is there, very very important in this video. Okay, thank you to all. If you like in this video, subscribe and share your friends. Thank you everyone.